Okay, we're now going to do lesson 3.6. Up until now we've been doing equalities, linear equations that create equalities, but now we're going to do inequalities, and we're going to talk about how multiplication affects inequalities. Okay, so we've done, as I said, everything up through here has been an equality. We're now going to talk about inequalities, but everything up through here still applies to inequalities. We're just talking about some special distinctions about inequalities. So, the big idea for 3.6 is that if you multiply each side of an inequality by a positive number, the direction of the inequality symbol stays the same. However, if you multiply each side of an inequality by a negative number, the direction of the inequality reverses. And we're going to explain why that happens. Okay, so the first thing we're going to talk about is just graphing an inequality on a very simple number line. All right, so first, let's talk about the symbols you use. Obviously, the symbols for inequalities are these that you're very familiar with: the less than and equal to, the greater than or equal to, the less than, and the greater than. The symbol for an equality is obviously the equality sign, the equal sign. And you also have something called double inequalities, and they use the exact same symbols. Here's an example of an inequality, x is greater than 3. A very similar one of an equality, x is equal to 3. And here's a double inequality. X is greater than negative 3 and less than 3. Okay, now in an inequality, you have an infinite number of answers. It's, x is greater than 3 means it's 3.1, it means it's 4.8, it's everything after that. In an equality, x is equal to 3, obviously the only possible answer is 3. And in a double inequality, you have more than one answer, but there are endpoints to each of those answers. So there's a defined number of answers that make that true. Okay? All right, so next thing you have is something called a boundary point. Okay? A boundary point is where an inequality ends, okay? And we'll talk about that in more detail when we talk about graphing it. An equality has no boundary point. It only has one solution, and it has no endpoints, which double inequalities have. Okay, so and this will be more clear when we do this line right here about graphing them. Okay, so when you graph an inequality, and you might have had this before, you put, if it's a x is greater than, you put an open circle right here, meaning it does not include the 3, but this red arrow right there says it includes everything greater than 3. When you graph an equality, you just put a dot right at the spot that makes it true. And when you graph a double inequality, you do similarly. If it's the the less than symbols, but does not include the equal, then you have open circles saying it's here at negative 3 and positive 3, but it doesn't include them. Now, just so you know, you might have heard this in a prior class, prior year, if it has the greater than or equal to, or the less than or equal to, those dots would have been filled in. Okay? In those cases, those dots would have been filled in. Okay, then the last thing on this is, how do you write this in set builder notation? Well, if this is your solution, then in set builder notation, x is greater than 3. X such that x is greater than 3. If this is your solution, then x such that x is equal to 3. And if this is your solution, it's x such that x is greater than negative 3 and less than 3. And the reason you need to know that is because it's important to think about what is your domain. What are the numbers that make sense for my situation? Okay. One more thing before we move on to the next slide. I said here that there's a finite number of solutions, and that's a little bit untrue because there is an infinite number of numbers between -3 and 3, but the point I was trying to make is it doesn't go on endlessly. It has a beginning and ending point. All right, now let's talk about how multiplication affects inequalities. All right, this is a little bit complicated of a graph, but we're going to do it, step by step and break it down. Okay, so there is something called the multiplication property of equality, and it has two parts. This left-hand side is part 1, and this right-hand side is part 2, and we're going to talk about them independently. So on the left-hand side, I have a group of numbers starting as low as -10 and going as high as 15, and I've put them in consecutive order where -10 is less than -6, etc. I'm going to multiply each of those numbers by 2, and I'm going to get this next line right here. Okay, so -10 times 2 gives me -20, and then all the way up to 15 times 2 gives me 30. So that's where all those numbers came from. All right? So obviously, if I have a -10, okay, and it's less than 15, which is obviously true, and I multiply both sides by 2, my resulting answer, which is -20, is still less than this resulting answer, which is 30. Okay? So that's the multiplication property of equality, part 1, that says, okay, the multiplication property of part 1 says if x is less than y, okay, x is less than y, and then I have a number a that's positive, and I multiply x and y by a, I still have a result that's less than this result. Okay? When I had -10 and it was less than 15, and a was 2, a positive number, the result was still less than that result. Okay, now here's where the interesting part happens on the right-hand side. I have the same set of numbers, -10 all the way up to 15 in consecutive order. Instead of multiplying by a +2, I'm going to multiply by a -2. And this is where the interesting part happens. When I take -10 and I multiply it by -2, -10 times -2 gives me a +20. When I take 0, the middle one, and I multiply it by -2, 0 times -2 gives me 0. When I take 15 and multiply it by -2, 15 times -2 gives me -30. So instead of them lining up and still being in consecutive order, when I multiply by a negative number, you can see they all flip. You know, the ones that are over here that are the smallest become the largest, and vice versa. All right, so what that means in terms of this property is, if I have a number, -10, and it's less than another number, 15, but I multiply both sides of that equation by a negative number, I need to change this in here. Okay? See that right there? That's the really important part. So, a -10 times a -2 gives me 20. A -15 times a -2 gives me 30. So I cannot say that the left-hand side is still smaller than the right-hand side. I now have to say that the inequality has flipped around. And that's the multiplication property of equality, part 2. If I have a number x, and it's less than a number y, and I have another number a, which is negative, and I multiply a times x, and I also multiply a times y, the inequality symbol needs to flip. Okay, so let's see how that affects our ability to solve equations. Or inequalities, rather, not equations, inequalities. I'm going to solve an inequality that looks like this. And here's an example. -7x is greater than or equal to 126. That's in the form of ax is greater than or equal to b. This is ax is greater than or equal to b. Okay, and I'm trying to solve for x, so I've got to get rid of a. A is negative 7, so I'm going to divide both sides by negative 7 to get rid of a. All right, but because of the property we just learned, I also need to use the multiplication property of inequality and flip the inequality symbol to this direction from this direction right there. So instead of being greater than or equal to, the result is now going to be less than or equal to. Okay? So I've divided both sides by 7 or negative 7 and gotten x is less than or equal to negative 18. All right, it's really important when you do these to check them, okay? Because I guarantee you there's going to be errors if you don't check them. So do this two-step check, which says take your original equation, negative 7x is greater than or equal to negative 7x is greater than or equal to 126. Take the original equation. Take both parts of your solution. So take your first part of your solution and say x is equal to negative 18 and put it into your original equation and see what you get. So negative 7 times negative 18 gives me 126. Is 126 less than, remember I flipped it over now, or equal to 126? Yes, it is. Now, that's step 1 of the check. You have to try the equals part of this. The step 2 of the check is trying the less than part of it. So pick a number that's less than your solution. A number less than negative 18 is negative 20. And put that into the original equation. So negative 7 times negative 20 gives you a positive 140. A positive 140 greater than or equal to 126? My original equation? Yes, it is. Check. Okay? So that's showing you that really flipping that inequality is crucial to solving those problems. Okay, so here's the multiplication property of inequality in words. You may multiply both sides of an inequality by a positive number, and by doing so, you are not affecting the set of solutions to the sentence. But you could also multiply both sides of an inequality by a negative number, but then you must change what they call the sense of the inequality, which is simpler just to say, flip the inequality symbol. And that is 3, 6.